So we're getting ready to talk about a topic that many people have problems with. They just can't really get the concept of a reducing sugar and a non-reducing sugar. And it actually shouldn't be complicated at all. It should be very straightforward as long as you're looking for the right thing on the sugar compound. So we've got these things in carbohydrate chemistry that's called a reducing sugar, and then some sugars are non-reducing sugars. So we have reducing sugars and we have non-reducing sugars. Now, where do these names come from? Well, we're basically taking the name from how they react with silver. Because if it can reduce silver, then we're looking at a reducing sugar. If it cannot reduce silver, then that means it's a non-reducing sugar. So what does that mean, reducing silver? Well, if you go back and remember that Tollins lecture for 10 minutes that we talked about, that's basically what you've got to think of. Some sugars basically are put into solution and they can reduce silver, meaning reduce the charge in a way, right? So we can see this precipitate of silver to form, and some sugars, well, that doesn't happen. Some sugars can't reduce silver at all. So we need to figure out, well, which one of these would be reducing and which one of these would be non-reducing. Is there an easy way that we can kind of distinguish between them? And the answer is yes. If you have a sugar that has a true carbonyl bond in the form of an aldehyde, then that is a reducing sugar. So that basically means that all of our examples that we did with straight chain sugars had that free C double bond O group up at the top. All of those are classified as reducing sugars. If you have a C double bond O in the form of a ketone, those are also classified as reducing sugars. That carbonyl bond is reactive and it can react with the silver and reduce it. So that is fair game. It is free. It's available for the taking. So ketones and aldehydes, aka straight chains, and that's what I'm going to put over here, aka straight chain sugars, can react with this setup. Now, we know that the majority of sugars, however, are not open chain. The majority of the sugars are in rings. So, are rings going to be reducing or non-reducing? Well, as long as they are what we call the hemi versions of them, right? We've talked about these carbonyls that come in the form of aldehydes and ketones, and then we said they kind of make hemiacetals, and those are basically the ring structures that they begin to make, and those are okay as well. So as long as we have a ring structure here that has an OH group at this location, as long as we see that, then this is classified as a reducing sugar as well. So one carbohydrate that has formed a ring, no other reactions have happened, and that OH group is still on that anomeric carbon. That is okay. So that is a reducing sugar. What is a non-reducing sugar then? Well, a non-reducing sugar would be like something that we ended with last video. This is a sugar that did have an OH here, but this OH group has been removed, and this OH group has maybe been replaced with something else, some other type of bond. Let's say we go back to that previous example using ethanol. A new nucleophile has came in and substituted for the OH group. That is a non-reducing sugar. That sugar is not going to reduce silver. Not only that, but we're getting ready to talk about this thing called disaccharide. And sometimes disaccharides are a non-reducing sugar as well. So basically we see these sugars that hook up at this location, and that takes up the OH group that is free at that spot. So sometimes these disaccharides, or sometimes these Polysaccharides are non-reducing sugars because they do not have an available group that can reduce the silver for us. So that's all that we really want to say about the definition of reducing and non-reducing sugars. I don't want to go any deeper than that. So basically you're looking for a sugar with an aldehyde, a sugar with a ketone, or a sugar with a hemiacetal group. Those are all basically going to be classified as a reducing sugar. Anything else is non-reducing as far as we're concerned. So that's where this video is going to stop. It's probably my shortest video that I've done for you, right? So that's kind of strange. It looks like I should be talking more about reducing and non-reducing sugars, but that will happen a little bit later when we look at the qualitative analysis scheme for carbohydrates. So in the next video, we've ended here with this kind of concept of a disaccharide, and we're going to pick up with a disaccharide, talk a little bit more about a disaccharide structure, and see how it's different than a monosaccharide. So that's what's coming up. Again, you're almost finished. You can see that finish line. Keep running toward it.